Salut. Hello. I hope you are well. In today's session, I would like to speak to you about solid principles. The solid principles for software engineers help really to build better applications, more maintainable, cleaner, and easier to read, easier, like I said, to maintain, but also to refactor. We don't want to spend too much time refactoring something that could have been avoided. And also by using AI, the solid principles is always there to keep our application robust. So what is solid principle? Well, solid, it's a set of principles of rules to keep our software clean, the code to keep it clean, maintainable, scalable, and easy to work with different coworkers, teammates, and over time, you will not have spaghetti code. Spaghetti code is an anti-pattern where it's so hard to maintain that you break something new every time you add a new feature, for instance. So solid S is for single responsibility. It means we don't want to rely on other things, on other responsibilities. So single responsibility principle. For instance, if one function, one method does too many things, well, it means you violate the single responsibility principle. If you check different inputs, different types, or like we have one function that allows, let's say, different database engines, MySQL, Postgres, and other ones, it means clearly that it doesn't have one responsibility. If it tries to do something more than what it's supposed to do, or the same for the class, if you have a manager class that does also do things for a user or for an employee, it means it violates the single responsibility. So always keep everything as, okay, does it do only one thing and only one thing and not more? If it does more than one thing, it means it violates the single responsibility. One function shouldn't do more than one thing. So you have to split, you have to learn how to split your different the different things you have in the class and in methods into only one usage. The O is for open close principle. That means it should be open for extension. We want to be able to extend our code with interfaces, through interfaces, for instance, but closed for changes, closed for modification. So open for extension, closed for modification, because that will help you a lot to have to refactor your codes. It's really important. So for instance, dependency injection helps a lot to prevent having a code that breaks the open closed principle. When you use dependency injection, you allow your code with interfaces. Of course, you have an interface, a generic interface that adds a constraint but allows having new features in our existing code extension, but we don't want to have modification. We have one payment class that allows a lot of different gateways inside of the class. We have to update that same class every time we add a new payment gateway. Stripe, PayPal, Braintree. That violates the open-closed principle. Now, if I have one interface, one abstract class, gateway, and then I can inject in the gateway abstract class different payment gateways, and every time I need to add a new gateway, I will just add a new class that will be injected in the abstract class. It allows extensions. I can easily extend by having more and more payment gateways, but I don't need to modify anything. I don't need to change anything in my code, and that's good. Lipscov substitution, that's a little bit weird. It's when one method, imagine here we have one method, I don't have a pen right now. I have one in my bag, but that's okay. So let's say I have one function And that function we say, or we declare that in an interface that it's supposed, the output of that function, it's supposed to be an object or an array with specific keys. And if it doesn't follow what it should return, it means it violates the Lipskov substitution. The same way, if it throws an exception, a different exception that the exception it was expected to throw, it will break the Lipskov substitution principle. Now, if we always follow the same way, that function will return what it's supposed to. So we know, oh yeah, the output will be what we do expect. Then it means we do follow correctly the Lipskov substitution principle. Then, after Lipskov substitution, we are on the I, and I is for interface segregation. Interface segregation, it means that you shouldn't force the user to use and to implement things they don't need. That means if you do have one big interface as an API where you require, so you force the user to implement methods they don't even need, you violate the interface segregation. Instead, you should have small interfaces with little constraints as possible. You don't want to constrain too much because you want to keep your code flexible. And if your interfaces have a lot of constraints, you are forcing the user to use things they don't need, and you are also likely to violate the single responsibility principle as well. Because remember, single responsibility is about not having your code doing too much, not having your code doing something else that it's supposed to do. And when you are violating the interface segregation by forcing the user to use things they don't need, you may also force them to have more than one responsibility in your code. So always split your interfaces into small, lightweight, and minimum interfaces. That means you may have, instead of having one big user interface, you would have a few abstractions, and that means you will have credential interface, you would have password interface, you would have user details interface, you would have user location interface, you would have user bio or user description interface, user social media interface, you see? And that way you don't force them to have too many abstractions for things they don't need and they feel forced to, and at the end of the day they may also end up to violate the single responsibility principle, which is a really crucial one in my opinion too. And then the last one is about dependency inversion. That means you don't want your high-level modules, your high-level code to depend, to rely on the low-level code. For instance, if you have a user account class and it relies on password or credential class, you violate this because the user account class shouldn't know about passwords of the user. And what if after you get rid of the password for login into your web application and you only require one-time code, like you mention your email address and you receive a one-time code, or you mention your phone number and you receive by SMS a OPC, one-time code, OTC, or one passcode, one-time code, that violates the interface inversion. So the dependency inversion, my bad, dependency inversion. So what you want instead is to have interfaces. You want to have stable interfaces and you want your class to rely on something stable, which are very often interfaces instead of relying on low-level modules that might not be stable because they might change. And when you use interfaces to speak through low and high level modules, it will create a maintainable and scalable code in the long term, because you can change the way it works. The interface will still remain the same. However, the interfaces you use shouldn't rely on properties either. So that's also something important. But when you have, for instance, a database engine or database class, and then you have Postgres, you have MySQL, and you have MariaDB as the database engine, the database class shouldn't know anything about MySQL, Postgres, MariaDB. It shouldn't mention any names there. Instead, it should inject with an interface that will be database engine interface. We should be able to inject MariaDB, Postgres, or it would be MySQL, and the methods should be generic. So in the database class we would use all of the method names are generic, and then we just pass the database engine we want, similar to PDO in PHP. And when you use like query, we don't know if we are using Postgres or MySQL. We don't know, because it uses an interface and it uses generic method names. And this is really what we want to follow, and what the dependency inversion is teaching us. Dependency inversion is relying on interfaces and not having the high level modules, the high level code, depending and relying on low level codes. And that's it for the solid principles. You will see, thanks to solid principles, you will be able to have highly and reliable, scalable and maintainable code base, thanks to following a simple set of 5 rules. I wish you a beautiful day. In my case, the ones I use most of the time are single responsibility, open-close principle, the interface segregation, really good, and sometimes also the dependency inversion. So single responsibility, I think it's amazing. It's really helpful to have really good code. Open-close principle, it's always good. And then interface segregation should be there all the time. That's super important. And dependency inversion, it's very useful. It might require to code differently, but it should be always the case. It should always be, we should always follow that rule. Because if we don't follow the dependency inversion, it means our code will easily end up into spaghetti code. I wish you a happy, clean code journey, and again, by following the solid principles, your code base will not smell anymore. It will just be something chef kiss.